I have started teaching computer science to kids in the year 2018. Teaching computer science to 7, 8, 9 years old kids is not an easy task. Today I am going to share my experience in teaching computer science to kids of this age group. Initially, I teach them about programming. I started with Scratch. Once they got familiar with the basic Scratch blocks and advanced topics like broadcast, user blocks, and developed some applications, I thought of moving them to Java. Initially, I thought of using something like Greenfoot, which is visually far more appealing than plain JDK. But then I thought, without the basic programming knowledge in Java, that will be just a fruitless exercise. So I started with Eclipse and JDK. Initial 2 months the kids were trained on basic programming syntaxes like if, for loop, while loop, switch case, etc. Then they started learning about methods, arguments, return types, and all related things. This way they developed many small Java applications. They also learned about array and strings, etc. Now comes the object-oriented part. After few sessions, they were able to understand concepts of classes and objects, states, behaviors, constructors, overloaded methods, and many more. Now the different part of object-oriented technology, that is inheritance. I thought I will have to make an example of inheritance interesting. So this is one such example where it shows the power of inheritance by using an element class and having a method called make sound, which will be overridden in the derived classes. That is that when you derive this class and develop class like cat, duck, dog, lion, etc. Now the interesting part of this is that these classes, that these subclasses, not only override the make sound method, but it also physically makes sound. It not only shows its text just like text, but it also physically makes sound. So let me run this application so that you can get an idea of this. Okay, I'm running this application. So this is how I'm running this application. So this is enter 1, 2, 3 or 4 for sound of dog, cat, duck, all that. So I'm keeping 1. So this is how the programming is done. So, and no doubt they were very much interested, and they thought it's a very nice example of inheritance, because it is not only making them theoretical sound, but it is also making use actual sound of animal. So this is how I made it. I try to make it more interesting for the kids. So this is one thing. So for example, this cat and duck and dog, all these examples are being developed to make it more interesting, make the inheritance and overriding part more interesting. Now another important part that I must say here, see, in the animal class there is a private boolean domesticated, whether it basically shows if the animal is domesticated or not. For example, cat, duck, dog, these are all domesticated animal, whereas lion is not domesticated animal. Now I have told them that only protected and public members are being inherited by the subclass. Okay, so that's what they knew. Now see here I have developed with the animal classes type, I have created few subclasses, each dog, cat, duck, and lion. Now see here, every different object is showing is domesticated. So that means whether it is domesticated or not. That means although the domesticated variable is private in the superclass or animal class, all the subclass objects have its own copy of that member variable. So how is it possible? So they asked me a question that how is it possible, sir, when you said that this is only for protected and public data members. So I knew from my experience that all the superclass members are being have a copy of themselves in the subclass objects, but that's if I said it to a senior programmer, he could have understood it without any because he wouldn't have asked me any questions because of his inhibition. But these kids don't have any inhibition, so naturally they would ask me questions. Okay, so to convince them, I need to develop I had to develop a system where I showed him the memory architecture, memory layout of the subclass and superclass concept. Okay, and so that I can show them that each and every member variables of the superclass has its own copy in the subclass object. So that's what I have done, and that's the example I'm showing it to you right now. So graduate, so you got the point, right? Kids don't have any inhibition. They ask questions whenever they don't understand. This is a very important part. We cannot take kids just for the sake that they are kids, so they don't understand anything. So this is very important part. I have very important lesson I've learned while teaching the kids. So see, this is the example where I have shown them the size of superclass and subclass. I have created a superclass called experimental superclass. It has a int member variable. That means with the Java alignment it is 8 bytes, and then the experimental subclass, it has its own 8 bytes member variable. Okay, so that means if the subclass inherits the superclass member variable, the subclass object will have whatever superclass has inside plus 8 bytes, right? That's what is very important. Whatever superclass has plus is 8 bytes. Although superclass member variable is private, but still we will find that the subclass object is having a copy of the superclass object. So let me run this application. So you see, it is the so this is the result. Subclass bytes used in superclass is 16, bytes used in subclass is 24. We know that subclass has a private integer member variable that is 8 bytes long with alignment. So what it shows actually is whatever superclass has, subclass has that, plus it has its own 8 bytes. Okay, so this proves that the superclass, all the member variables of the superclass, irrespective of whether it is private, public or protected, has a copy of themselves in the subclass object. So this is how I had to convince them. This is very important lesson for me. We cannot take kids just because we cannot teach kids taking into consideration that they are kids. And this, to conclude this, I would like to say that while teaching programming to kids, they should be considered as inquisitive adult programmers and not kids. With that, I'm signing off here, and I'm sure that the next year, the 2019, will be a good year for me as well as my kids students. Thank you. Bye.